Good evening, everyone. Myself, Sana Sheikh, a first year PhD student from IIT Bombay, and I am a TA of NPTEL course named Symmetry, Stereochemistry and Applications. The course instructor is Professor Anshuman Roy Chaudhary from IISER Mohali. Today is the first week live session. In a live session, we are going to discuss the previous year assignment question, which will help you to solve the current year assignment question and better learning of the topic. Before starting the question answer session, I would like to give a brief introduction about the topic. So, today we are going to discuss the IUPAC nomenclature. What is IUPAC nomenclature? IUPAC nomenclature is nothing but the nomenclature of organic chemistry, and it's a method of naming organic chemical compounds which is recommended by the International Union of Pure and Applied Chemistry. So according to IUPAC rule, we have to divide any organic compound into three parts. The first part will be your substituent, and the second one will be your parent chain, and third one is suffix. So substituent is the any species which is attached to the parent chain. Okay. Then parent chain is the nothing but the longest linear carbon chain present in any organic compound, and suffix is the highest priority functional group present on parent chain. I hope all of you are clear here. Before solving the question answers, I will give some examples for better learning and better understanding. In the first example, we have to see here, according to the IUPAC rule, we have to find out the substituent, parent chain and suffix. So, first of all, we will see here suffix is present here. Suffix means highest priority functional group. So, in this compound, organic compound, you can see here OH is the highest priority functional group, and no any there is no other group present on this carbon chain or parent chain. So OH is the highest priority functional group. So we will consider this OH as a suffix. Suffix. I am writing S for suffix here. And now we have here parent chain. We have to find out the parent chain, and parent chain is nothing but the longest linear carbon chain. So here this is the longest linear carbon chain, and this is the parent chain present in this organic compound. Now, the third thing, we have to find out the substituent present on the parent chain. So, as you can see here, there is no substituent present on the this carbon parent chain. We will discuss the example with the substituent also, then it will be more clear to you. But here there is no substituent present on the parent chain. So that's why we will write directly parent chain name, because substituent is not present here. So the parent chain name is pent, because we have 5 carbon atoms. As we have 5 carbon atoms, we are writing here pent. Then all of you can see here at carbon number 4. At carbon number 4 we have double bond, right? So we will write here 4, pent 4, and this double bond is a alkene family. That's why we are writing here ene, right? We are writing here ene because it's a alkene family. So the name here will become pent 4 ene. Now you can see here at carbon number 1 we have OH group. At carbon number 1 we have OH group. That's why we are writing here 1 ol. OH is a alcohol group. That's why we are writing here ol. Ol is the initials of alcohols. So the name will become pent 4 ene 1 ol. Now the question arises here, how we are giving a numbering, how we are deciding from which carbon we have to give number 1 and 2. So all of you can see here, we have a highest priority functional group here OH. alcohol group. And the numbering will always start with the carbon atom which have the highest priority functional group attached to it. The carbon atom which is attached to the highest priority functional group will always uh, give a number 1. Always give number 1 to that carbon atom, and we will start counting from that side only. Okay, let's quickly do the second example. In second example, you can see here we don't have any suffix or highest priority functional group. Suffix or highest priority functional group is missing here. That means we have to find out now parent chain. Parent chain. So we have to give numbering from any side. Now you have to see here we don't have any other functional group, any substituent on the parent chain, but we have double bond. This is the double bond, and we have to prefer the numbering from the side uh, which give the lowest numbering to these carbon atoms which has double bond. So from this side we can see the carbon atom 1 and 2 have double bond, but from this side if we will give numbering it will become 4 5. You can check, cross check by yourself, but now I am counting from this side. The carbon number 1 have double bond, and total number of carbon present in parent chain is 5. So we will write here pent for 5 carbon atom. 1 because at carbon number 1 we have double bond, and ene means double bond because it's a alkene family, we are writing ene. So the name will become pent 1 ene. Let's move to the third example here. Now here you can see, first of all you have to check the suffix present on any organic compound. So suffix means highest priority functional group. So you can see here this is the suffix present in this example, NH2 amine. So amine group is present, so that means we will give numbering from this side. The amine group is present on which carbon atom we can see here, and it will be a number 1 carbon because we will start giving numbering from this side. Now the second thing, we have to find out the any substituent present on this carbon chain. Is there any substituent, any other chain or compound or anything attached to the parent chain? No, right? There is no substituent. That means we will start writing name with parent chain. Parent chain. First of all, we are writing substituent name, then parent chain, then suffix. But here substituent are missing. That's why we are writing parent chain name. There are 4 carbon atoms. You can see here, and we are giving numbering from right to left. So this is a 4 carbon atom, that's why but. The name will come start with but. And at carbon number 2 you can see here, at carbon number 2 we have triple bond. That means it's a alkyne family. So at carbon number 2 we have alkyne family, triple bond. That means we will write here but to wine. Wine wine is used for alkyne family. And now you can see at carbon number 1 we have amine group. That's why we are writing here 1 amine. At 1 amine. Suffix in last. We are writing suffix in last. So the name will become but2wine 1 amine. I hope all of you are getting here the concept behind the numbering. Now next example is this one, fourth one. Here again you have to find out the suffix present in this organic compound. As you can see here, there is no suffix present here, and no substituent is also present in this parent chain or organic compound. There is no substituent, no suffix. We have to directly give the parent chain name. And as I told you, you have to always start giving the numbering from the lowest side. So if you will give numbering from this carbon atom, that means from right to left, you will see here the carbon number 3 will have triple bond. But if you will give numbering from left to right, you can see here at carbon number 2 we have triple bond. So we will always consider the lowest number, that means from left to right one. Okay, then there are 5 carbon atoms, so we will write pent. It's a pent family. Now we can see here at carbon number 2 we have a triple bond. So this organic compound is belongs to alkyne family. uh, that's why we will write here 2 wine, 2 wine. So the name will become pen 2 wine. I hope all of you are clear till here. We will do some more examples, then we will start solving the questions. This is another example. Now you have to find out here the suffix present in this organic compound. So here you can see we have OH group. OH is the highest priority functional group present in this organic compound. So that's why we will write here, we will consider this one as a suffix which we will write at the end of the name. Now we have to find out the parent chain present in this organic compound. So you can consider this longest linear carbon chain. You can consider this methyl also in longest linear chain, but it should be linear. That means this methyl will goes out. But because of simplicity and for understanding easily, I am considering the longest linear chain, not the this diabetic chain. Both are the same. You can consider anyone, but here I am taking only this as a longest linear carbon chain. Now we have to give numbering. Now we have to find out the substituent present on the parent chain. This is the longest linear carbon chain is your parent chain. This OH is a suffix, highest priority functional group. Now the third thing we have to find out the substituent present on this longest linear chain. So this is the methyl group present on parent chain as a substituent. CH3 group, methyl group is present. So now we will start giving numbering from prefix, because substituent are used as a prefix. Always we have to write first. Prefix are always written first. So here we will write methyl group name, but before writing the prefix we have to give the numbering to the carbon atom. So this is a parent chain. As I told you, you have to always start giving the numbering from the highest priority functional group present. If you will see here, if I am giving numbering from left to right, it will become 1, then 2, 3, then 4. You can see here the OH group is present on carbon number 3 from left to right numbering. But we can see here, if I will give numbering from right to left, this will become 1, this is 2, this is 3, then it will become 4. So at carbon number 2 we have the OH group, the highest priority functional group. That means we have to consider this numbering from right to left, from right this way. So according to this way, you can see at carbon number 3 we have substituent present, methyl substituent. So we will write here 3 methyl. You can see here 3 methyl, and the longest linear chain have 4 carbon atoms. That means it will become bute. Bute means 4 carbon atom. We will write bute here. 3-methyl bute. Now you can check any double bond or triple bond present in your parent chain or not. So you all of you can see here there is no double or triple bond present in your parent chain, right? Your parent chain have only single bonds. That means it's a alkane family. That's why we are writing here ane, alkane. And because uh, there is no numbering of double bond and triple bond, that's why we are writing directly butane. And at in last we are writing the suffix name. So suffix present here is OH group, alcohol group. So that's why we are writing here ol. But it is present on which carbon atom? Carbon number 2. So the name will become 2-ol. 2-ol. So if we will combine all the substituents and parent chain suffix name, then the name will become 3-methyl butane 2-ol. Right? The correct IUPAC name will become 3-methyl butane 2-ol. I hope all of you are understanding here. Let's do one more example. Okay. So now in this organic compound we have to find out the longest linear carbon chain present. So that will become our parent chain. So you can see here this is the longest linear chain present in current organic molecule. Now you have to find out the highest priority functional group. Which one is the highest priority functional group present in this organic compound? See here we have different types of functional group. You can see here this is the methoxy, this is halogen, bromine, and here alcohol. But the OH group is the highest priority functional group. If you will see the priority, the OH has the highest priority. So this is the highest priority functional group, and that's why we will consider this OH as a suffix. That means it will come in last while we are assigning the number, not number, name, sorry, the name. In name it will come last suffix. Now we have to give the numbering to these carbon atom. So as I told you, from the highest priority functional group we have to start giving numbering. The highest priority functional group should come on the lowest carbon lowest number of the carbon. So you can see here if we will start from this side it will come on second carbon atom. But if you will start from this side it will come on 1, 2, 3, 4, 5 carbon atom at 5. So we will consider this way from right to left. At second carbon atom we will take OH group. So then so now start giving numbering. This is a 1 carbon, 2, 3, 4, 5 and 6, right? Now at carbon number 2 we have OH group, but this is a suffix, so we have to write this one in last. Now we have to check substituent present on parent chain. So there you can see here at carbon number 5 we have two substituents. One is methoxy and one is bromo. So we will write in alphabetical order the substituent name. If only one substituent is present, then it's okay to write directly that name. But we have two substituents, so we will consider in alphabetical order. So the name will start like 5. At carbon number 5, we have bromo group. So bromo is and methoxy. We have bromo and methoxy, but bromo is come first alphabetically. When we will arrange in alphabetical order, bromo will come before the methoxy group. That's why we will write here 5 bromo, and at carbon number 5 only the methoxy group is present. That's why 5 methoxy, 5 bromo, 5 methoxy. Now we have to find out the longest linear chain name, the parent chain name. We have 6 carbon atoms. That means it's a hex group. We will write here hex family. Now you have to check any other double bond or triple bond is present on parent chain or not. You can see here there is no double or triple bond present. That means we have to write ane. Alkane family, that means ane. Hexane. This is the hexane. So you can see here the name is 5-bromo, 5-methoxy, hexane, and the last suffix will come here. So this is at carbon number 2. That's why we are writing here 2 and ol. 2-ol. So the correct IUPAC name is 5-bromo, 5-methoxy, hexane, 2-ol. Not 2-bromo, 2-methoxy, hexane, 5-ol. We have to always give numbering from the highest priority functional group. Right? Okay. Now let's move to the next example. Uh, this is your previous year assignment question. We will discuss here. This is the first question. Write the IUPAC name of the following compound. So here you have to find out the longest linear carbon chain or parent chain. So anyone, which is your longest linear chain? We don't. You can see here we don't have any suffix present here. Suffix means highest priority functional group. We don't have any suffix here. There is no functional group is present. Only double bond and triple bond is present. So we will consider that one. Okay. Suffix is means highest priority functional group is not there, and this is the parent chain. Highest priority functional group is here double bond and triple bond. Now we have to find out any substituent present on this chain. So you can see here we don't have any substituent present here. So this is the longest linear chain directly, and this is the parent chain. So we will start giving numbering like parent chain. So how many carbon atoms are there? You can count here. And from which side you have to start giving numbering. It's depend on the these two functional group, that is double and triple bond. So always remember triple bond have highest priority over double bond. In this case, we will consider this triple bond as a highest priority functional group or suffix. Okay, so the name will the suffix name will come in last, and the numbering will start from suffix side, as I told you in previous examples. So the numbering will start from triple bond side. So this will become 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So there are 11 carbons present in this organic compound, and it's the longest linear chain part. So we will write undic. Undic is only for 11 carbon atom. For like we are writing for 1 carbon meth, for 2 eth, 3 prop but pent. Say in similar way for 11 carbon atom we are writing undic. Now you can see here at carbon number 7 we have double bond, right? We have to always write suffix in last. That's why we are not writing here triple bond here. That's why we are taking double bond. And carbon number 7 we have double bond. That's why we are writing here 7 ene. Ene is alkene family, double bond. Now in last we will write suffix. So at carbon number 1 we have triple bond. That means it's the alkyne family. So we will write here 1 wine. The name will become undic 7 in 1 wine. The first option is correct. All of you got it? Okay. Now let's move to the second question. Here, now in this case, you have to find out the longest linear chain, longest linear carbon chain. So which is the longest linear carbon chain here? Anyone? Yeah, this one. As I told you, you have to find out the longest linear. So in case of linear chain, linear carbon chain, not if any other atom is present, then it will not consider as a linear chain. So here we can see, here we have three carbons, right? Three carbon chain. So this and here we have two carbon. Here also we have one carbon directly. These two carbon are attached with oxygen. So this is not the longest linear carbon chain. That's why we will consider this as a parent chain. This three carbon. So this is the longest linear carbon chain. Okay. Now we will find out the we already find out the parent chain. This is a three carbon chain is a parent chain. Now we have to find out the suffix and prefix present in this organic compound. So you can see here nitrogen and oxygen group are there, but amine is always considered as a highest priority functional group over oxygen alcohol oxygen functional group. So because we have here amine, nitrogen, it will become highest priority functional group. That means this will become suffix and it will come in last. You will write the suffix name in last. Okay. Now we have to find out the substituent present on parent chain. So here you can see here substituent is this methoxy group, methoxy methyl group, this ethyl group, right? So we will write in this way. So first of all we have to write the prefix name. These are two substituent, methoxymethyl and ethyl. That's why we will write here the substituent name. So because alphabetical order is follow for prefix name or substituent name, we will consider ethyl over methoxymethyl. So we will write first ethyl because ethyl is comes first in alphabetical order. Then the second substituent present on this carbon longest linear carbon chain is methoxymethyl. Methoxymethyl. Why I am writing methoxymethyl? Because this OMe group is methoxy and this CH2 is methyl substitute. That's why the name will become methoxymethyl. Now the we have to write the parent chain name because we have already written here substituent name. Now parent chain uh, we will start giving numbering to the parent chain from the side which suffix is present. So you can see here suffix is present. That's why this carbon is 1, this is 2, and this one is 3. So at carbon number 1 we have this suffix group. But before writing the suffix we are always writing the parent chain name, right? Suffix is always written in last. So we will write here parent chain name. So these are three carbon atom. That's why 3 methoxy propyl. You can see here 3 methoxy. Methoxy is a substituent present. That's why we are writing substituent first. At third position methoxy is present. That's why we are writing here methoxy propyl. 3 carbon atoms are there. That's why propyl. Why I am writing propyl not propane? Because this nitrogen is considered as a suffix here, so the name will and substituent is present on this nitrogen. That's why the name will depend on this nitrogen, not this chain. So this is a propyl. This is a substituent. 3-methoxypropyl. Now because this is a tertiary amine, so the name will become amine. And nitrogen is a amine family member. That's why the word, the name amine will come here. So the name will become ethyl methoxymethyl 3-methoxypropyl amine. The option number 2 is correct. Next question. Question number 3. You have to find out the longest linear chain present in this compound. So, before finding out the longest linear parent chain, you have to find out the suffix and prefix present in this compound. Suffix means highest priority functional group, and prefix means substituent present on parent chain. So, here you can see we have double and triple bond on this organic compound. So, triple bond will always come first. It's the highest priority functional group as we have discussed in earlier examples. So this is the suffix, highest priority functional group. This is our suffix. Now you have to find out the prefix here. Prefix means substituent present on the parent chain. So before finding out the prefix parent chain, you have to find out the longest linear chain. So which is the longest linear chain here? As I told you, you have to always start with with a giving numbering with suffix carbon atom. The carbon atom which have suffix means highest priority functional group, that will become your carbon number 1. Okay. Now we can take this as a longest linear carbon chain. You can cross check this one. You can consider this group also, this vinyl group, but here I am taking this one as a highest longest linear chain, because both if you will give numbering, you will see both are the same, both are nothing but the same. That's why I am writing here, I am taking this one as a longest linear chain. Now you have to start giving numbering. This is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, that means it's a undig. This parent chain is belong to undig family, undig. So we will write the name undig, but before writing the name parent chain name, we have to write the substituent name present on parent chain. So which substituents are present on this parent chain? Anyone? You can see here at carbon number 6 we have this methylene group, right? And at carbon number 8 we have this propynyl group. So because we are giving numbering from this triple bond side, so we have to write 6 and 8 substituent. But in methylene and propynyl group, uh, methylene will come first, because alphabetical order, in alphabetical order M is coming first. That's why we will write here 6 methylene, 8 propynyl, 6 methylene, 8 propynyl, undig, undig. Now you can see here at carbon number 9 we have double bond, right? Carbon number 9 we have double bond, that's why we will write here 9, and double bond because it's from alkene family, we will write here ene, and at now in last we will write the suffix. So at carbon number 1 we have triple bond, that is our suffix, so we will write here 1 wine. Wine means alkyne family, triple bond. So the name will become 6 methylene, 8 propynyl, undig, 9 ene, 1 wine. The option number 3 is the correct one. Let's move to the next example, next question. Okay. Now here again you have to find out the substituent present, then parent chain name, and suffix present here. Okay. So here you can see we have two functional groups, three functional group actually. This is a double bond, this is a halogen, and here is carbonyl. So because double bond is a least priority functional group here, in chloro and carbonyl group, we will always carbonyl group will consider as a highest priority functional group. So here the carbonyl group is the highest priority functional group. That means it is our suffix, right? Then the other functional group will become your prefix. So this chloro will become your prefix. Okay. Now you have to start giving numbering here. So because this is a bicyclo system, so two rings are attached to each other by a bridge compound. So you can see here we have bridge here. I will write here. So here we have three carbons. If we will consider these two are bridging carbon atom. So sorry for the interruption. So here we have carbonyl group as a highest priority functional group. So we will start giving numbering from bridging carbon atom. So this is a bicyclic system. So we will write here. We will start giving numbering from here. 1. This is 2. 2. Sorry. Here, yeah, we have to give the highest number, lowest number to the bridging compound, because bridging will have highest priority. So here we will give here numbering 1, then this will become 2, this is 3, this is 4, this is 5, 6, 7, 8 and 9, because we have here two rings which is bridged by this two carbon atoms. That's why we are writing here one bridge in one ring we have three carbons, right? 1 2 3, this chloro one. So we will write here 3, bicyclo 3, and here we have two carbons, one is carbonyl one and carbon number 7, 6 and 7. So we will write here 2. Then this is bridged by another two carbon atom alkene group. So we will write here 2. So this is a bicyclo 322, bicyclo 322 system. Okay. Now this is a parent chain name, bicyclo 322. But we before writing the parent chain, we have to write the prefix. Prefix is chloro here and this double bond. So this double bond is a part of parent chain, but this chloro is a prefix. So we will write here at carbon number 4 chloro is present. So 4 chloro, 4 chloro. Now parent chain name is bicyclo 322, bicyclo 322. Uh, Here you can count the 9 carbon atoms are present. So this is a nonene system. So we will write here known, 9 carbon atom known. So here known. At now you can see at carbon number 8 we have double bond. This is alkene family. So we will write here known 8 ene alkene. That's why ene. Now at last we will write the highest priority functional group. So highest priority functional group is carbonyl present in this organic compound, and it's present at carbon number 6, sixth position. So we will write here 6 one. It's a ketone family. That's why we will write here one. So the option number 1 is the correct one. Okay. So I hope all of you are clear here. This is the next example. Next question. Question number 5. So you can see here. This is also the bicyclic system, but this is the Indian system. Indian means one six member ring and one five member ring. I hope all of you know what is Indian. This is an Indian family. I will draw here. Sorry. Five member ring. This is the Indian. Okay. So here you can see this is not the Indian, but a derivative of Indian. So parent chain is Indian here. So you have to write Indian as a parent chain name. But before writing the parent chain name, you have to find out the substituent present on parent chain prefix, and in last we have to find out the suffix. So suffix means highest priority functional group is ketone, right? On. So here we have two ketone groups, so both are the highest priority functional group. That's why we will consider both as a suffix. Now you have to find out the prefix or substituent present. So if you will compare this structure with Indian, you can see in Indian we have uh, four double bonds. That means we have less hydrogen compared to this derivative. So here substituents are hydrogens which are present here in Indian case. Because we are considering Indian as a parent chain name, that's why we are writing hydrogen as a substituent or prefix. So you can compare here how many hydrogen atoms are more here. 4, right? You can see here we have this carbonyl group here. Suppose we have here, and this part is same as this one. So two hydrogens are here, are extra, right, from Indian. If we will compare with Indian, here we have two hydrogens. In Indian we have 4 in 5 member ring. I will show here. It will become easy to count. Here we have one proton, second two proton, and here two proton, right? That means total 5 proton in 4 proton. Sorry, total 4 proton in 5 member ring. Now you can see here we have 4 proton, right? So it's same as Indian, 4 proton. Now we will check the 6 member ring here. In 6 member ring, here we have one proton and another one, another one, and here one, right? 4 proton again, 4 proton. Now we will see here we have here 2, 2, 2, 6 proton, right? 6 proton. So 2 protons are extra, 2 hydrogens we can say. So here two hydrogens are more. So that means we have two hydrogen substituent on 6-member ring. Now you have to check the other hydrogens also. So at carbon, this bridging carbon atoms here, these two are bridging carbon atoms. You can see we don't have any proton, but here we have one proton, one here and one here, right? That means we have two more protons here. So that means in total we have four extra hydrogens compared to indene structure. Four extra hydrogens, right? Now we have two more protons because he- here we have instead of this four double bond, we have here there is no double bond, but here we have carbonyl groups. We have to count the numbering. We have to count the numbering here. So here we have 8 proton. In this indene we have 8 proton, but here if we will calculate 2, 4, 6, 8, 10, 12, 12 proton. So this is the hexahydrate group. So here we have 6 hydrogen because we have two carbonyl groups. That's why we are considering here 6 hydrogen extra. So the name will start with substituent. So hexahydro indene. At carbon number 1 and 5 we have ketone group. We will give numbering from this side. Always the smallest ring will consider as a prior group. So we will start giving numbering from this carbon atom. 1, 2, 3, 4, 5. So at carbon number 1 and 5 we have ketone group. So we will write here hexahydroindene 1,5-dione. 1,5-dione. So the option number 2 will be the correct one. Okay. If you guys have any difficulty or doubts, we can discuss in the next lecture also or our coming live session. So here we can see we have sparrow compound. Sparrow compound. That the difference between bicyclo and sparrow compound is that in bicyclo, in between the two cyclic ring, there are two carbon atoms. That means the two carbon atom uh, are attached. We can say attaching the two different rings means two carbon atom are shared by the two different things. You can see here this is the bicyclo system. That means two carbon atoms are shared by two rings, but in case of a sparrow only one carbon atom is shared by both the rings, two rings. So that means it's a sparrow compound. For giving the sparrow compound, we are writing here uh, because sparrow is our parent chain, so we will consider sparrow as a parent chain compound, right? So you can see in options we have sparrow option only in 1 and 4th option, so the two options will get cancelled there, right? Now okay, sparrow, these are our parent chain. Sparrow is a parent chain compound. Now we have to find out the prefix and suffix present in this organic compound. So prefix is a function substituent present on the parent chain, and suffix is your highest priority functional group. So as we have discussed earlier, in case of ketone and halogen group, we are considering ketone as a highest priority functional group. That means ketone is our suffix. So we have to write suffix in last. While labeling any organic compound, we have to write suffix in last. Now, then halogen will become, your chlorine will become prefix or substituent present on parent chain. So the name will start with your prefix only. So I will give here numbering. So whenever we have spiral compound, in that case we have to give numbering to the lowest cyclic ring. Lowest carbon cyclic ring means smaller ring. So this 5-member ring is a smaller ring. So we will gives numbering from this ring. So carbon number 1 will always be the next carbon to the spirocarbon. This carbon is a spirocarbon or a tetra substituted carbon. So the number will start always next to this carbon atom. So this is the 1 carbon atom. This is the 2, 1 and 3, 4. Now we have to move to this carbon 5, 6, 7, 8. Okay. So we are going this way. So here you can see at carbon number 8 we have chloro group, right? So we will write here 8 chloro, 8 chloro. Now this is a spiral system with how many carbon atoms? We will complete the numbering here, then it will become easy. 10, right? 10 carbon atoms. So spiral 10 carbon atom, but we have two cyclic rings here. One is here 5-member and one is 6-member, and these two rings are shared by this single carbon atom. So here we will give numbering to the lowest ring first. As I told you, smaller ring will come first. So smaller ring, wait, I will erase here. Yeah, now uh, you have to consider only the carbon atoms outside the sharing ring. So this is the carbon atom which shared between the two rings. So you don't have to consider this one. Uh, Apart from this carbon atom, we have 4 carbon atoms present in this ring, except from this carbon atom. So that means it will become 4. Because this is a sharing carbon atom between the two rings, so we will not consider this carbon as a part of smaller ring, and not as a bigger ring also. It will it will not consider in both the rings. So we will write here 4. Then here we have 5 carbons, right? 1 2 3 4 5. So we will write here 5, 4 5. Now these are 10 10 carbon atoms are present in this system. That means it's a deca system. Dec. So we will write here dec. Right? Okay. 8 chloro, spiro, 4 5 dec. Now you can see here at carbon number 6. At carbon number 6 we have double bond. Right? We have double bond. So this is a alkene family. So we will write here 6 ene, because at carbon number 6 we have double bond, 6 ene, 2 on. Ketone is our suffix or a highest priority functional group. That's why we are writing in last. So at carbon number 2 the ketone group is present. That's why we will write here 2 on. So the name will become 8 chloro, spiro, 4 5 dex 6 ene, 2 on. The option number 1 is correct. Okay. Question number 7. So here Again you have to find out the longest linear carbon chain, that is parent chain, then prefix and suffix. So here you can see we have two functional groups, cyano and acid. So between the cyano and acid, acid has the highest priority over cyano group. So this is our suffix. This acid will become our suffix, and this cyano will become prefix or substituent present on the parent chain. So here we have to find out the longest linear parent chain. You can see here, this is the longest linear carbon chain, right? Okay. So as I told you, you have to always start giving numbering from the highest priority functional group. So this carbon atom will become 1 because this is the highest priority functional group, acid. 1, then this is 2, then 3, 4, and this one is a 5. So there are 5 carbon atoms. So the first of all we have to write the substituent name. So at fourth position we have cyano group. We have cyano group at fourth position, right? Now we have to write the parent chain name. What is the parent chain name? 5 carbon atom is there, that means it's a pent. Pent. Sorry, here, pent. Now we have to see any double bond or triple bond is present or not. Any other prefix. So here we can see we have double bonded carbon number 2. So we will write here 2 ene. Ene means double bond. 2 ene. Okay. Then at carbon number 1 we have suffix, our highest priority functional group. So we will write here 1, or because it's 1 we don't have to write also, so we can directly write oic acid. Oic means carboxylic acid. For carboxylic acid we are writing oic. So the name will become 4-cyano pen-2-enoic acid. This is the correct name. But if you will see examples here, options, we don't have option with pentenoic acid. Pentenoic acid. That actually this one is the correct one, pentenoic one. But because we don't have option here, so we have to find out the second option also. The first, this name is correct. All of you remember this. Pentenoic acid is the correct one. But from examples, from options, we are finding the correct one. So as I told you, 4 cyano group is present. So 4 cyano here. This option number 2 and 4. Now we have to see 4 methyl. So you can see they have considered here in this example. They have considered this is the longest chain. 4 carbon atom as the longest chain. They have considered in this way. So at carbon number 4 we have methyl group also. So 4 methyl substitute, 4 cyano, 4 methyl. Correct? Now you have to find out the, because they have considered 4 carbon at 4 carbon at as a parent chain. So the name will become bute. Bute means 4 carbon is present in parent chain. Bute. At carbon number 2 we have double bond, so bute 2 ene, and acid is present at carbon number 1, so oic acid. So the name will become 4-cyano 4-methyl bute 2-enoic acid. So option number 2 will be correct one according to these options. But the correct answer is 4-cyano pen-2-enoic acid. Okay. This is the question number 8. In this question, again you have to find out the longest linear carbon chain and suffix and substituent present on that carbon chain. So here, as I told you, we have acid group amine, alcohol, and ketone all are there. But which one is the highest priority one? Carboxylic acid. It has two oxygen and H. If you will see the priority order, you have to check the priority order of functional group. You will see acid have the acid is has the highest priority over ketone, alcohol, and amine group. So this is our suffix. Acid is our suffix and highest priority functional group. Now we have to find out the parent chain here. So longest linear carbon chain is our parent chain. You can see this is our parent chain. Okay. Now we have to check the prefix or substituent present on the parent chain. So we have seen here there are three prefix or substituent present on parent chain: ketone, alcohol, and amine. But as I told you, we have to start giving numbering from the side which have highest priority functional group. We have to give numbering from the that carbon atom. So this carbon atom has acid group. So we will consider this as a 1. Carbon number 1, 2, 3, 4, 5, 6, 7. Okay. Now we have to write prefix name first. So you can see at carbon number 3, 4, and 6 we have substituents. But according to alphabetical order, we will write their names. So in amine, alcohol, and ketone, which come first? Amine. Amine starts with A. That's why. So we will write here 3 amino. 3 amino. So you can check in option. 3 amino is present in only 2 options. 3 amino. Then oxo and hydroxy group. So in oxo and hydroxy, hydroxy will come first. So we will write here 3 amino, 4 hydroxy. At carbon number 4 we have hydroxy group. Hydroxy. So 3 amino, 4 hydroxy, 6 oxo. At carbon number 6 we have oxygen, double bond oxygen, ketone group. That's why we will write here 6 oxo. 3 amino, 4 hydroxy, 6 oxo. Now you have to find out the parent chain name. So this is a 7 carbon chain. That's why it's hep chain. So we will write here hept. Now we have to check any double or triple bond is present in parent chain or not. So there is no double or triple bond. That means it's an alkane system. So we will write directly heptane. Heptane. This is the parent chain name. Now you can see here at carbon number 1 we have acid. So because at carbon number 1 we have acid, we can write or not, it's up to you. So we will not write here 1. Directly we will write heptane noic acid. Heptane oic acid. Heptanoic acid. Because it's at carbon number 1. So we are not writing 1. The option number 1 will be your correct answer. 3 amino, 4 hydroxy, 6 oxo, heptanoic acid. You can cross check other options also, then you will get the correct answer. This is the question number 9. In question number 9, again we have to find out the prefix, parent chain, and suffix. The same thing. So here we have two functional groups, right? Two ketones. Both are ketones. So both are suffix here. So we will consider both as a suffix. Okay. These both are suffix. Now we have to find out the longest linear carbon chain. So I am starting from this functional group because we have to give lowest numbering. You can see. Okay. This is the longest linear carbon chain present in this organic compound. As I told you, linear chain. We cannot consider these all these three CH3 group in this parent chain because it will not become linear. So we are considering the linear chain. So this is the longest linear chain present here. Now start giving numbering. From which side we will give numbering? Which has lowest which has the highest priority functional group on lowest carbon atom. So from here it will give numbering 1, 2, 2, 3. So this ketone group will come on third carbon atom. But from here when we will give numbering 1, 2. So at carbon number 2 we have ketone group. So we will give numbering from this side only because this is the lowest carbon number. 3, 4, 5, 6, this is 7, this is 8. Okay, so this is the 8 carbon atom system, 8 carbon system. Okay, so here we will write first prefix name. So how many prefixes are there here? Here we have prefix means substituent present on parent chain. So here we can see these two methyl are substituent present on parent chain. So this is our parent chain which is highlighted by red one, and these two are uh, substituent present on that parent chain. So we will write here at carbon number 7 we have two substituent. So 7, 7 because we have same substituent present on same carbon on 7 carbon number. So we will write 7, 7 dimethyl because 2 methyl group is present. That's why we are writing here dimethyl. Dimethyl. Now we have to write the parent chain name. So here we have 8 carbon atom in parent chain. So the name will start with oct. The name will start with oct. Now you have to check any double bond or triple bond is present or not. So here you can say in parent chain there is no double or triple bond. That means it's a alkane system. So we will write here octane. Octane. Okay, not we will not write E. E means ending. So octane. Okay. So now in last we will write our suffix or functional group. So we can see here at carbon number 2 and 6 we have two ketone groups. So we will write here 2, 6, 2, 6 dione because two ketones are there, di. That's why we are writing di, and one is for ketone, dione. Okay, so the name will become 7, 7 dimethyl octane 2, 6 dione. The option number 4 is correct. Okay. Now next question. Now here you can see this is the last question of this assignment, and again we have to find out the longest linear carbon chain present in this molecule. So what will be the longest linear chain? Anyone? This one only. Why I'm not considering this one? Because it has oxygen here in between. And here we are talking about linear chain. Longest linear carbon chain. So oxygen is there, that's why we are not considering as a longest linear carbon chain. Okay. Now we have to find out the prefix and suffix present in this example. Prefix means our substituent present on longest linear carbon chain, and suffix is the highest priority functional group. So here we can see here we have ester group. ester group on carbon. We have ester group on parent chain. So this is the highest priority functional group over amine. We have amine also, but the ester has highest priority compared to the amine group. So that's why we will consider ester as a suffix or highest priority functional group. Our suffix. Now the second thing, we have to give the numbering to the carbon atom. So as I told you, whenever we have suffix or highest priority functional group, the numbering will start from that carbon atom. So here this is the carbon number 1. This is 2, 3, 4, 5, 6. Okay. So from writing before writing the parent chain name, we have to write the prefix name here. So prefix is amine here. So we will write amino. So at fourth position amino group is present. So 4 amino. Now we have to find out the other substituent or prefix present. So you can see here this third butyl group is present on ester, right? If we will consider this carbon, wait, this is the longest linear chain. So at carbon number 1, we have this methoxy, third butoxy group, right? This is the third butoxy group present on carbon number 1, right? So we will write here third butoxy because it's also a prefix or substituent present on parent chain. So we will write here tertiary. That means tertiary butyl because 4 carbons are there. That's why it's butyl. Tertiary butyl group. Butyl. Now we have to write the parent chain name. So what is the parent chain? Here we have 6 carbon atom in parent chain. That means hex, right? So we will write here hex. Now we have to check any double or triple bond present on this parent chain or not. So you can see here on parent chain we don't have any double or triple bond, double carbon carbon or triple carbon carbon bond. So we will write here ane. This that means it's a alkane. So hexane. We will write here hexane. Okay. Now and last you have to write the suffix name. So what is the suffix name? Highest priority functional group. So highest priority functional group is ester here. So as for ester we are writing oat. O oat. Oat. So the name will become 4-amino tert butyl hexanoate. So option number 1 is correct. In IUPAC we are writing O8 for ester. 8 for ester. So hexanoate. Okay. You can cross check the other 3 options also, which is not correct. So the correct option is 4 amino third butyl hexane oat, which is the option number 1. I hope all of you are clear till here. If you guys have any difficulties or doubt, you can ask me in next class or live session, or you can ask me in comment box also in YouTube. On YouTube in comment box you can write your questions also. Thank you.